Hello students, welcome you all again to this video lecture series on chapter mechanical testing of metals. In first destructive testing we have seen tensile testing of the metals. Secondly, we have started this impact testing of the metals. So in impact testing we have seen why the impact test is necessary, what are the types of material that can be tested by impact test, and what is the procedure to carry out this impact test. Then we have seen two types of impact test are there, Charpy test and IZOT test. Charpy test we have seen in detail what kind of specimen is required and how that specimen is placed, like a simply supported beam, and a V notch is there, and V notch is exactly in the opposite direction of a hammer heat. So that we have seen, and we have also seen how to calculate the impact energy and toughness of the material by using this Charpy IZOT test. Second test now we will see in this video, that is a IZOT test. Previously we have seen Charpy V notch test. Secondly we will see now here IZOT test. So this is also a similar kind of test. With this test also we are going to find out the impact energy as well as the toughness of the material. So IZ impact is defined as the kinetic energy needed to initiate the fracture and continue the fracture until the specimen is broken. This test can be used as a quick and easy quality control check to determine if a material meets the specific impact properties or to compare the material for the general toughness. So this energy also, so this test also will give you the same two things, that is the toughness as well as the impact energy. In this also the equipment used is a similar kind of equipment, but just small difference is there. Here the test specimen is not a simply supported beam. Here the test specimen will be placed exactly vertically, and the procedure will be again similar procedure. Just here you have to place that test specimen exactly vertical, you have to prepare the test specimen, and here the test specimen is having certain standard size. Standard size of this test specimen for this IZOT test is 75 mm length, and cross section again 10 mm by 10 mm. V notch is also prepared on that bar, but that V notch is not exactly at the center. The IZOT test specimen is held rigidly in the vice type of fixture with the notched sides facing to the direction of impact. So in last test, what is Charpy test, we have seen there that V notch is exactly in the opposite direction of a hammer hit, but here hammer will hit in the same direction as that of notch, on the same side as that of notch. The center line of this notch must be in the plane of that voice top. So in that second diagram you can observe the center line of that notch is exactly parallel or exactly matching to the plane of voice top. Once that specimen is placed in, the hammer is released from the preset height, that is initial height capital H, and allowed to strike the specimen and thus fracture it to the V notch. So here also that V notch is prepared with the 45-degree angle and 0.25 mm base radius, but just here difference is center exactly, V notch is not exactly at the center, it is above certain height from the center and is placed exactly in the voice such that that V notch plane will be exactly parallel to the plane of voice top. And test specimen sizes here also difference, 75 mm length, 10 mm by 10 mm cross section. In last IZOT test, sorry, Charpy test, we have seen the standard test specimen size as a 55 mm length, 10 mm by 10 mm cross section, again 2 mm deep V notch and 45-degree angle of that V notch and 0.25 mm radius at the base. So here also in IZOT test, V notch is similar kind of V notch with the similar dimension, that is 2 mm with a deep, 45 mm angle, sorry, 45-degree angle and 0.25 mm at the base radius. But the length of specimen here is a 75 mm instead of 55 mm. Just this is the difference, and position of that specimen is vertical here. So here also we are finding the impact energy by same formula. Initial energy we can find out mgh minus final energy. Difference between initial and final energy will give you the impact energy, and toughness you can find out by one simple formula, impact energy divided by area of the specimen. So by this we can calculate the impact energy and toughness in case of a ISOT test. So this is regarding ISOT test. In next lecture we will find out the difference between this Charpy and ISOT test.